This is the stoichiometry unit video number 1, which will discuss calculating molar mass and percent composition. Our objective is that by the end of this video, you will be able to calculate molar mass and percent composition when given a periodic table. Materials you should have present in front of you while viewing this video to make it more effective would include your periodic table, the calculator you plan to use on tests and quizzes, a pencil, and either notes or a capture sheet. Molar mass is defined as the mass in grams for 1 mole of a substance. We've talked about moles in the past. Remember, a mole is just a way to group things in chemistry. In the real world, you might group eggs and donuts in terms of dozens. You might group shoes into pairs. You might group pieces of paper into reams. In chemistry, you're going to group atoms, molecules, compounds, ions into moles. And then we're going to use these moles to determine how much of a substance you have during a chemical reaction. Let's get started. Our first one is finding the molar mass of H2O. There's 3 main things you need to find out in order to determine the molar mass of any compound or molecule. That would be the elements present, which in this case are hydrogen and oxygen. How many atoms you have of each. So we have 2 hydrogens. We're going to write that down. 2 hydrogen and 1 oxygen. And then the mass of each one. We found the mass on an earlier unit. So taking a look at our periodic table, the mass of hydrogen is 1.0079. We're going to round everything to one number past the decimal place, which means 1.01 will be the mass of a hydrogen atom. For oxygen, the mass of one atom is 15.999. When we round that, we're going to get 16 for the mass of one oxygen. Now, when we deal with just one oxygen and one hydrogen, we do it in AMUs. But we're doing molar mass, or the mass of a mole. So we're going to do it in terms of grams. Now at this point in time, we need to find out how much mass all the hydrogen has and all the oxygen. Each hydrogen atom has a mass of 1.01 grams. We have 2 atoms, so we're going to have to multiply those together. And when we do, the total mass of all the hydrogen put together is 2.02 grams. We're going to do the same thing with the oxygen. 1 times by 16 is 16.00 grams. At this point, this is the total mass of hydrogen and the total mass of oxygen in water. If we add those together, we're going to find out the total mass of a mole of water. So once again, since we're dealing with molar mass here, our answer is going to be in terms of grams. And then to remind ourselves that we're doing moles and not molecules, we're going to say per mole. Let's try another one. Magnesium nitrate has 3 elements: magnesium, nitrogen, and oxygen. There's 2 magnesiums, made a mistake there. We have 1 magnesium, because there's a little imaginary 1 there. 2 times 1, we have 2 nitrogens. And 2 times 3, we have 6 oxygens. Now, using your periodic table, similar to this one, we'll find that the molar mass, or the mass of magnesium, is 24.31 grams, because we're dealing in terms of moles. Each nitrogen is 14.01 grams. Notice we're still rounding things to 2 numbers past the decimal place. If you would rather write down all the numbers, that's fine. But you need to have at least 2 past the decimal place. Now we're going to do the atoms times by the mass to get all the mass of that element. So 1 times 24.31 is 24.31 grams. 2 nitrogens times by 14.01 grams is 28.02 grams of nitrogen, total mass of the nitrogens. And 6 times by 16 is 96.00 grams. Now that we have the total mass of all the magnesium, nitrogen, and oxygen, we're going to add everything together to get the overall grand total called the molar mass. And this is best found using your calculator. So our answer is 148.33 grams per mole. Per mole, just remind ourselves that this is the mass of a whole mole. So how do we do percent composition? Well, percent composition is always done in terms of mass for each element in a compound. And percent composition can be used to determine which type of compound you have. The overall formula is given as the following, and this comes straight from your math class. Any percentage is equal to the part that you're studying divided by the whole thing times by 100. But let's see how to use that. Going back to our water molecule, let's remind ourselves about information we found on the previous slide. Hydrogen has a mass of 2.02 grams. That's what we found out. And the oxygen had a mass of 16.00 grams. So the overall grand total of water was 18.02 grams. So using this information that we already calculated, let's find percent composition. So starting with hydrogen. The percentage of hydrogen is going to be part, so the part we're studying, which is hydrogen, and that's 2.02 grams, divided by the total, which is the water molecule, or 18.02 grams. Then we're going to times that by 100%. So in the calculator, we're going to do 2.02 divided by 18.02, get that answer, times by 100. And when you're done, the percentage of hydrogen will be 11.21%. Now notice how the units cancel. We have grams on the top and grams on the bottom. They cancel each other out, and we get percent as our only unit. Okay, let's try the oxygen one now. Percentage of oxygen is, looking at the formula, the part we're studying, which is oxygen, and that part is 16 grams. Divided by the total, which is water molecule, or 18.02 grams. When we're done doing that, we're going to times it by 100. So use your calculator and go ahead and plug this in. And when you're done, you should find the percentage of oxygen is 88.79%. And just a little reminder, our units do cancel. We had grams on the top and grams on the bottom, so they cancel each other out, and percent is our remaining unit. Excuse me. Let's try the magnesium nitrate. Just a reminder of what we found out in the past. Magnesium had a mass of 24.31. The nitrogen had a mass of 28.02. And the oxygen had a grand total mass of the 96.00 grams, which means that our overall molar mass for magnesium nitrate let's write that down, is going to be 148.33 grams. Okay, at this point a good idea would be to stop your video, do your percentages for magnesium, nitrogen, and oxygen, and then double check your work. Okay, so our percent of magnesium is the part we're studying, which is magnesium. It has a mass of 24.31. Divided by the total, which is 148.33. Then times by 100. So in the calculator, 24.31 divided by 148.33, get that answer, times by 100. And our percentage is going to be 16.39% magnesium. Let's try it now for the nitrogen. Percent for nitrogen is the part that is nitrogen, which is 28.02, divided by the total, which is 148.33 grams. And when you're done, times that by 100%. So in the calculator, we're going to get a percentage of 18.89% nitrogen. This number makes sense. It's a little bit higher than magnesium's, but then the mass of nitrogen is a little bit higher than magnesium as well. Now let's calculate what we have for oxygen. The percentage of oxygen is the part that is oxygen, so 96, divided by the total, or the whole thing, which is 148.33 grams, times by 100%. When you do that in the calculator, you get a grand total of 64.72% oxygen. And this also makes sense. It's much higher than the nitrogen's amount, but then look how much higher the oxygen amount was as well. Before I sign off, I just would like to say, if you're doing your setups correctly, but you're getting the wrong numbers in your calculator, that means you're using your calculator incorrectly. Please see your teacher or a teacher with the same kind of calculator to get some extra help on how to use your calculator correctly.